Okay, lots of questions coming in on our YouTube lately, and so we're just gonna answer a bunch of them. So I've got the questions here. This guy says, how would you screw the ridge cap down? So this is in a video where we were talking about never screw on the ridge of the tin, on the ribs of the tin, I should say. You're gonna, in most types of metal that we're using in Western Canada, you're gonna screw in the pan and the flat to get a proper seal. On the ridge cap, of course, it's running on top. So the ridge cap would be like on your gable, you know, you're gonna run it down the ridge and it's gonna cap where those two metals end, and then you're usually gonna vent that so you can get good airflow coming in through your soffits and out the ridge. That ridge cap is gonna be screwed to the ribs. Now what we do is we use a 2-inch screw on the ridge cap, which goes right through into the strapping below, because the ribs are 3/4 inch high. The screw's 2 inches, so it's gonna go down and into the strapping by 1.25-ish, minus a little bit of metal thickness, right? Then we make sure that screw goes through the vented foam to pinch it in there as well. So that's how you're gonna screw ridge cap down. What do we got next? In the market for a roof, what about the pitch makes it different? Okay, so this person's asking, what about the pitch of the roof makes it different? And specifically on this video, we were talking about how a steeper pitch makes it more expensive, and the reason it does is there's just more labor, more work, right? So just imagine doing a very low pitch roof, which means like a low pitch would be like a 312, 412. And what that means is that for every 12 feet or 12 inches or whatever, 12 units of measure you go this way, you're gonna go up 3. So you can see, like, you go 12 this way, you go up 3, it's not very steep. But if you have a 12-12 pitch, that's very steep. You're gonna go 12 this way and you're gonna go up 12. So now you got this a much steeper roof. So that's how the pitch is measured. It's like how many units this way for how many units up. A steeper roof, of course, you need, you know, imagine working on a 12-12, which is quite steep. Like, you're gonna be slipping off there. You're gonna have to be tied in, leaning in the ropes. You're gonna have to be working with the ropes. You might need a ladder that hooks over the top so you can stand on that. Whereas if you're working on a 312, 412, even a 512, you can move around on that roof very easily. You're still tied off for safety, but you can run around on that roof. You know, you're not gonna slip, you're not gonna fall. So that's why the pricing changes as it gets steeper over 12-12. Of course, at a certain point, you're gonna actually have equipment. You're gonna have to bring in a man lift and work on it that way. Like, cause there's some roofs that are, you know, 16, 18, 12, very steep, almost a wall, and you're not even able to stand on them. So you're gonna have methods like maybe a ladder from the ground, maybe you're gonna have to do scaffolding, maybe you can actually bring in a man lift, depending on the site. Obviously, all of that is extra cost. This one seems like it's more sarcasm. We were talking about checking your screws, replacing the screws, that's a good way to stop leaks. And he says, wait, so should I fix a hole in my roof to repair the leak? Am I getting that right? So it is probably a sarcastic response, but you actually might not notice that the screws are loose. It's not like there's just this big hole where if the screw came right out, yeah, you'll see a hole. But if the screw, you know, the washer's deteriorated, maybe the screw was done too tight and the washer squished out and it deteriorated and washed away, you might not even notice that unless you know what you're looking for. But you may notice it on the inside is in the form of a drip. But water travels too, right? So the water might get through the screw. It might not drip till 3 feet down over here or 8 feet, or it might drip in a totally different spot. So you might say, hey, I've got a drip over here, but actually it's coming in over here. So if you're not looking at your roof correctly, it's not like there's big gaping holes or like obvious holes, but if those screws aren't done right, you could have leaking. We had a lot of comments talking about screw piles. One thing that came up was, hey, what about uplift? Because we're talking all about like the weight of the building it's sitting on there. So they're also designed for uplift. Think of a screw, like when you screw a screw into wood, like to pull that screw out is very difficult, right? So it's the same thing essentially. You've got a helix on the bottom of the screw pile, goes down in the ground. To pull it out, you'd have to lift all that earth. And depending on what that is, like when you've hit that torque for the weight, the uplift is always gonna be less than the weight. And another question with that, with the open pole barn, asking about, is that design okay for high winds? So that building specifically, and most of our buildings are gonna be engineered, and they'll be engineered for your exact location. So if it's engineered, yes, it's designed for the high winds that you get in that location. So there's bracing requirements, and a lot of times people look and they're like, well, there's not enough bracing, because they want to see like all these big bracing. But the way the bracing works, it's all designed and engineered, and there's a lot of bracing in the roof trusses that actually ties everything together and keeps the building from racking over. As long as they're designed for high wind, like if you just stick up a bunch of posts and throw a roof on top, it might be weak or it might not work, but yeah, as long as you design it right. Hey, if you have questions that aren't covered in this video, you can hit the link below and you can book a time to talk to us, or just throw the questions in the comments and we'll try and get to them and answer them for you. We got people concerned about boards rotting, sitting on the concrete. It's kind of a crazy thing because literally every house, like I used to frame a lot of houses, and in British Columbia, all the houses have SPF sitting basically on the concrete. Like you'll run a sill gasket in there, that sill gasket doesn't do anything for, you know, if there's moisture or whatever. So they're all built like that, the wood's on the concrete. If you're in a super wet area, you got water all the time up against it, yeah, I'd probably be concerned about it, but otherwise not going to be concerned about the wood touching concrete. I mean, all your basement walls, all that stuff, it's all touching concrete, and people put like sill gasket under them thinking it's doing something, and half the time it's not even put in there properly, or it's not wide enough or whatever. So I would not be worried about wood touching concrete. It's not a concern unless you're in a really wet spot or you got crazy water going on. Why is screwing directly into OSB a problem? Yeah, well, there's several reasons that screwing into OSB is a problem, but if you have an exposed fastener metal roof and you put the screws through into OSB, what happens is they poke through on the inside, and yes, your attic space is vented and everything, but an attic gets hot. Get in your attic in the middle of summer, and even though you've got vented ridge, you've got vented eaves, you might have whirly birds on the top, you might have vents in your gable, it's still going to be a lot hotter in the attic, and even in the winter it's going to be hotter in the attic. Typically your insulation isn't perfect, you're going to get heat from your house into the attic. It could be minus 30 outside and it could still be like, I don't know if it'd be 0 in the attic, but it's going to be a lot warmer in the attic. I don't know what the exact difference is, but what happens if you have an exposed fastener screw, think of this for a second, and it's screwed through OSB, you've got the metal screw and it's outside in that minus weather, cold weather. It's also that same screw comes right through and it's inside underneath the OSB, poking through into this warm space, so it's going to condensate on that warm screw. You're going to get moisture on that, and eventually, it takes some time, but in about 10 years of that OSB is going to start to get a little bit spongier. It's going to expand the hole, and then because of heat and cool, you know, the screw's expanding, contracting a little bit, the metal's moving a little bit, it's getting wet a little bit, and it expands that hole in the OSB, and the screws start to back off. Now, you're going to see that with exposed fastener metal roof on a strapped roof as well, because you're not going to get that condensation because the screw's buried, but you're still getting the movement. So, you know, 15, 20, 25, I've seen roofs 40 years old where the screws are still in there good. It's going to last a lot longer if that screw's not poking through an OSB or a plywood and condensating in the cooler weather. So that's the biggest problem. And then with the movement and only having, you know, 3/8, 1/2 inch, 7/16 of material, that screw's going to start to pull out.